Welcome, everybody. So Seun started 14 weeks ago, so this is his last week on the internship, and we worked together to create the foundations of interactive visualizations in Cirq. I believe it's a very important addition to the project, and he's going to talk about all the details and new features that we introduced. Seun is was amazing to work with, and yeah, I'm just going to leave it up to you to ask questions and go into the details. Good luck, Seun, and then yeah, let's hear it.
Excellent, excellent. So actually, we'll just go on to the next slide. I'll introduce myself. So as you can see, my final intern project was Cirq Typescript visualizations. So at a high level, introducing Typescript to the Cirq repository as a whole, which allows people to create, build, and use 3D visualizations. A little introduction on me. As mentioned before, my name is Seun Omonije. I'm a rising senior at Yale University. Got into quantum computing about a year and a half ago, I'll say. Found a book written by Jack Hederi in Barnes & Nobles, actually, and picked it up, got interested in it. Since then, have taken some classes at Yale about it. A board member of the Yale Undergraduate Quantum Computing Group, helped lead a hackathon with about 2,500 people. Actually, this last semester, quantum computing, Balint and Doug and Tanuj were all a part of that hackathon. So that was pretty cool. But yeah, really excited to show you guys my project and what I've been working on. So let's start with the why. Like, what is the purpose of the work that Balint and I have done this summer? I think the number one feature, the number one like why, is to facilitate explanation and exploration in quantum computing. There's a lot of tools out there for researchers, students, and educators to go ahead and explain circuits or like work with different algorithms or do things like that. But basically my project kind of takes that to the next level and introduces not only like widgets right now that other people can go ahead and use, but also like allows these same researchers, students, and educators to build more features on top of this, which should kind of explode and kind of send a shockwave through, to use big language, throughout the quantum computing community. But also this feature kind of gives Cirq the first ever interactive and portable 3D visualization widget framework among all the quantum computing frameworks. And I'll go into more depth about what this exactly looks like later in the presentation. But at a high level, you can take these circuits that otherwise are very complex and kind of unintuitive to see at the beginning and then view them in 3D, which makes it look really cool. And then, as I mentioned before, with the development environment, internal and external contributors can easily build new widgets and add to this as they like, which kind of gives it limitless potential. So looking at what practically has changed in the Cirq repository with this project. So we introduced a Cirq web package, which is a whole new sub-package in Cirq, where, like I said before, internal and external users can take advantage of browser-based visualizations in Cirq. This Cirq web package is composed of three main like sub-modules. You have like your TypeScript development environment, where developers and people who are like understand Python, TypeScript, and want to create can go ahead and build new visualizations and improve existing visualizations on top of Cirq web. And then two like mock prototype widgets. They're probably a little farther than prototype. They're probably good for production now. Obviously, there's more improvements that can be done upon, which I can talk about later. But an example 3D block sphere where users can generate state vectors in Cirq and then see how they're oriented on a 3D block sphere. And also a 3D circuit widget where people can create grid circuits in Cirq and then generate an interactive 3D model that can be viewed in Collaboratory or Jupyter notebooks or sent to others as a standard HTML file. And the cool thing about that is that sending it to others doesn't require the recipient to have Cirq installed. So yeah. So I'll start off talking about sort of kind of diving into how this project was implemented and the different features so that people know how to use it. And also just showing some cool things. The slides link in the that I linked into the Cirq doc has like the RFC pull request documentation, which you can see here. So feel free, if you want to get a really in-depth detail what's going on, to click the links and see what I've done. So to give a big overview of the TypeScript development environment, I won't talk too long about this because it's not the main point of the presentation. But as you can see here through the diagram, we have our general Cirq package, and then the Cirq web submodule, which then points to all this other stuff on the right. So the TypeScript development environment is built on top of like Node.js and NPM. So Node.js is a JavaScript runtime, which allows you to run JavaScript outside of the browser. And in that Node.js environment, we use NPM to manage different packages. So things like Webpack, Puppeteer, different frameworks that make it easier for us to go ahead and develop inside of this environment. There's also some configuration files that we had to create, and then some like setup TypeScript code to make everything work the way we want to do. But then you see at the bottom, like the unit and end-to-end testing, the in-browser development with hot reloading, the TypeScript bundling, and the collab and Jupyter Notebook support are all products of what you see above, like the things that hit into the user. And so the cool thing about this environment is that it's as configurable as a developer wants it to be. So if you're not really, if you don't really care about actually like understanding what's really going on under the hood, you can just build visualizations. It's very easy, very quick, very fast, and you can kind of run from there. If you want to kind of get more in depth, you can do so as well. And obviously, like there's different styles and guidelines that we have to follow for the Cirq repository in general. But developers really have a lot of freedom in how they want to develop and build new things and kind of help this thing grow. One point that I wanted to touch on, especially with the development environment, is the bundling of the different files. So in order to run these widgets in the browser setting, we have to have JavaScript code that executes in the browser. But one issue with creating these large visualizations using JavaScript is that it's not really the best language to go ahead and build these large systems or large complex like code bases with. So what we do is we make sure that everyone can, we require everyone to develop in TypeScript, and then we use like the Webpack framework to go ahead and bundle everything together and convert it to JavaScript, create this bundle file, which then the user can import into a random HTML file or into a specified HTML file, and then build a visualization off of. The only, maybe some like downsides, alternatives to using like Webpack in general, this is an example for all the external frameworks, but it could be a bit heavyweight. So it can do a lot of things that we don't really need it to do. So for this, the purposes of this project, it like works really well. It's fast. It does like hot reloading is included. It's easy to spin up a server. But some improvements that could be made in the future maybe would be to figure out how to use like a CDN so that we don't have to like import Three.js every single time we run a server, or even kind of develop our own way to bundle and compile the TypeScript into JavaScript. But that's just a small feature to touch on, and it's not really that important to the overall TypeScript development environment as a whole. So moving on to the actual widgets, I'm going to talk now about the Blocksphere widget more in depth. On the slides too, we have the pull request and documentation links there as well if you're interested in that. But a quick start or functionality overview of how this looks. So as you can see in the code snippet here, you can prepare your state. The 0 state right now is prepared here, but as you can see in the diagram, the plus state is what's on the Blocksphere. But you basically just take that vector that you want, convert it to a valid state vector in Cirq, and then just pass it into the Blocksphere constructor, and you can generate an HTML file or display it in a Jupyter Notebook, and you get the output as seen on the right. This will support any valid state on the Blocksphere, and like mentioned before, It's fully interactive in the Jupyter Notebook, which I'll demo later. And then the file is portable, so you can send it to anybody. A quick overview of the implementation of the Blocksphere. I kind of went over it a little bit, but we have like our user-generated state vector goes to the Blocksphere class. Then inside of the Blocksphere class, there's this method called getClientCode, which is actually part of it's an abstract method for all widgets that is required for every single widget that you develop in Cirq Web. But what getClientCode does is it takes the HTML and JavaScript code that you as the user specify. So when you bundle your Typescript file, there's different like exported functions that you kind of make the Three.js objects and everything kind of like hidden, and then you have your like linking function that you take your Python code, serialize it, and then pass it into the function signature. getClientCode will do that and then kind of generate the entire HTML output, and then from there you get your visualization. Now, practically from the Python side, that looks like the two functions that you can see on the right over the dotted line. The repr HTML magic method, which allows visualizations to be displayed in the Jupyter Notebook by just using display, and then the generate HTML file, which will go ahead and build that file for you. Some improvements on the Blocksphere. So Suresh, which is one of the UI designers that we talked to earlier in the internship, and actually created a really cool internal slide deck about what we can do to kind of build this thing up. He built this redesign, which I actually have like a pretty solid prototype of already in one of my branches in my fork. But just another way to view the Blocksphere, make it look a little more visually appealing, match it with the Cirq brand. But that's something that, I mean, contributors can easily pick up and kind of make this thing look pretty, put some lipstick on it and make it look good. So that's one improvement that can be done with it. And then some other improvements. There are a few current issues with it right now. I think, so one thing that we would like to do too is have like output JPG and animated GIF for the Blocksphere, because basically all output requires the browser, because you can't run JavaScript in like a static file or anything like that as of right now. So what we could do is kind of have, rather than generate an HTML file, generate a PNG, which could theoretically already use one of the packages installed in the development environment, Puppeteer, to just go ahead and take a screenshot of that image and then go ahead and output it to the user. And then animated GIF, you can kind of take a screencast over a few seconds, have a camera default, like rotate among a certain axis, and then you can generate a GIF, which then you can send. And then this is more of a like Three.js kind of getting into the meat of it, but a world units to pixel alignment issue where Three.js right now uses this measurement or units called world units, which can modify the scene in the different Three.js meshes depending on the like browser or computer that you're on. And so just having some sort of set alignment so that it's very specified to each user and each developer how measuring goes, and how these, like, let's say if I want a Blocksphere radius 1 or radius 5, how is that going to be standard across all devices? Making sure that that's taken care of is another improvement that can be made to this. So now the Blocksphere widget was a good introduction, but the coolest part, in my opinion, of this whole project is the 3D Circuit widget. As everything else, I have a link to the RFC in the pull request for those who really want to look into it. But yeah, so to give a quick functionality interview of what was before this project. Let's say I wanted to create a grid circuit. This is a 5x5 square or grid. And I wanted to we're using the Cirq testing to just generate a random circuit. Obviously, the qubit connectivity and topology has to match. So you're going to have some sort of like connections among gates. That's not possible. But I generate this random circuit and I want to see what it looks like. I want to like show people, hey, this is a quantum circuit. This is what I would have to offer them. And if I'm a researcher and I'm familiar with Cirq a lot, I mean, I can understand that. I can know what's going on. But to educators, to students, to other people, and even just internally, it's just not as visually appealing. and not as intuitive as it could possibly be. So now after Cirq Web, we have this new 3D circuit visualization where you can go ahead and take that same grid circuit object, pass it into our Circuit 3D constructor, as you can see at the bottom here, and you can get this 3D image with a camera where you can move the camera around, see what's going on, and actually see what this would look like in real life. Like if for example, a circuit on a chip or something like that. And you can iterate through the different moments, kind of see time scale. There's more features too, where like you can change different camera modes, which I'll show later. You can reset the camera back to the beginning, and then zoom and move and kind of see what's going on at every moment. It's a little easier to see than what it was before. Another cool function of the 3D circuits is label overriding. So basically, and I'll go into it further in depth when we go through the the symbols and basically how these circuits are serialized. But if you have certain circuits, so at a high level, we just take the circuit diagram info from that current circuit and then display it onto the box. But if there's something that I wanted like a measurement to say this specific thing, or if I wanted to override different gates or operations and make them say what I wanted to say, you can see the code here. You can go ahead and create a new like symbol resolver instance and pass it through into the circuit constructor and make the different labels or operations say whatever you want them to say. So you can see here I have a little fun thing saying oh Seun Prezi, where now every instance of a Hadamard gate will say Seun Prezi, and then every instance of a Y gate will say hey. And so it's very easy. You can just pass in the symbol resolver. And the way it works too is that every single, it always gets the latest iteration of the resolvers. And I'll talk more about what exactly the resolvers are later. But with the latest iteration, it will go ahead and build it. And then with anything that's not done, it will just default back to the default resolver, which we had implemented ourselves. Another feature that you can do is scale circuits. So as you can probably tell, as circuits get more and more complex and more dense, they can be a little harder to see. So you can go ahead and add a padding factor into the constructor, which will go ahead and spread the circuit out for you so you can see kind of easier what's going on at every moment and every time step. So that's another like cool feature, which is pretty like easily doable. And you can kind of pass in any single number that you want. It takes integers, it takes floats. So yeah. Another like cool bonus feature is the scalability. So right now I outputted a 20 by 20 lattice of with a random assortment of operations. It scales pretty well and it's pretty performant. In the demo, I think the default one right now is like a 10 by 10 lattice, and it works well. The camera works well. It will go ahead and zoom everything out so you can see it. Obviously, you're not really going to get too much information out of this because it's a big mess. Maybe if you scale it and want to like go through different moments or different like little sections of the circuit, you can see what's going on. But even in the ASCII diagram in the Jupyter notebook, I tried to print this out and I think it was just way too hard to read. And there were some lines like all over the place. I just think, I mean, obviously there's no 400 qubit circuit that's going to be done soon. Well, yeah, but yeah, it's just a cool, fun feature. So a quick overview of the implementation. I'll spend a bit of time on this slide and kind of talk about the thought process and some of the alternatives. But as you can see here, you have your user-generated grid circuit object that gets passed into the Circuit 3D class. There's a method called build 3D symbol, which refers to different symbol resolvers that, as I explained before, we have like a default symbol resolver that just goes ahead and takes the circuit diagram information already in Cirq for each label, and then goes ahead and builds different 3JS meshes based off of that. Or like builds different 3JS like or Python serialized objects based off of that, which then later will be built into 3JS methods. So then after you have your symbol resolvers and it goes through all of that, then it goes ahead and serialize the circuit into a way that can be easily converted into Typescript. And then that kind of big function, that big serialized like list of operations gets put into the TypeScript through the function signature. And then we have a Symbol 3D object builder that goes ahead and builds these meshes from that serialized info, and then builds the HTML and JavaScript code using a 3JS bundle file, which then gets you your visualization output. Some different alternative implementations that we thought were, rather than like serializing everything ourselves, going ahead and using like Circuit to JSON and then parsing through that JSON and building the TypeScript based off of that and the different meshes based off of that. That was my first thought, actually, and that was really what I wanted to at the beginning. But after thinking about it more and more, having full control over how everything is serialized makes it really easy, and it helps us understand exactly what's going on. It's good for debugging, and it's also like simpler because there's a lot of different ways that the JSON can go, a lot of different types that you have to account for, and just making sure that we serialize into our own type and kind of having the general case and then kind of narrowing our scope from there if we need to was really helpful, and it worked out pretty well in the long run. We were also thinking about potentially having 3D circuit info into the Cirq core repository. So like having another method rather than circuit diagram info, 3D circuit diagram info. But we really wanted to have the Cirq web package kind of be its own standalone from the rest of Cirq. And I think now that we have built that, that's obviously the best way to go. But that was another alternative that we considered. And then also having specific Python types when serializing. That was kind of like a very quick initial thought because it would make it easier, and we could kind of do some cool things in the Python, knowing the specific type. But just having a general type and passing different parameters and doing that proves to be much faster and much more efficient. So some improvements that can be made to the 3D circuit diagrams, the orthographic camera, which I'll show you later, can be cleaned up. So right now, what we do is just like zoom in and out to fit the entire circuit on the screen. And then we also set the camera to a position on the circuit where it will block out part of the circuit. And so as you can see here, some of the meshes are outside of the view of the camera, and you get that weird like omission in the middle. I can actually, so with time, I can work on this issue and fix it up. Bala and I, a few days actually, were just going through and looking at it, and we kind of figured out the problem there. But that's definitely an improvement that could be made if anyone is interested in that. And then moment filtering. So this is a cool thing that I think would be extremely useful just for the visualization in general. Having different sliders at the top to where you can hide and show moments. So I actually built this prototype kind of a while ago, so this is a bit old. But having it to where you can see exactly what's going on at each specific moment in the circuit, like for more complex circuits, that would be actually super, super useful to see and make it very easy to explain and show people how the state is possibly changing as it goes through the circuit. And then in addition to just general moment filtering, just having general animations and things like a tooltip that will provide like like a matrix representation of a gate when you hover over it with your mouse. That would be something that's just would help interactivity, kind of make it look cooler and kind of set it apart even further. So now I'll give a quick demo of the block sphere and the 3D circuit widget. A lot of the stuff was already covered in the presentation, but as you can see here, I'm in a Jupyter notebook, and I want to go ahead and create a block sphere and use it in 3D and see it in 3D. So I have this state here I have the plus state, I have these pre-prepared states, but as you can see here, I just converted to a valid state vector, passed in the block sphere, and now I have this 3D sphere that I can go ahead and move around. And then if I want to say, okay, let's put it in the 0 state, I can just change this to 0. And now you see the vector is pointing onto the 0 state. We can move it around and see, zoom out. And then if let's say I want to have a random superposition, or I'll have this random state, I can go ahead and put this in. and then it will point to a random location on the block sphere, and you can analyze where exactly it is. So that's like the first thing. And then for the 3D circuits, we're in the Jupyter notebook and we build our own circuit here. We go ahead and just play it. So right now I have a 10 by 10 lattice, and I want to run it in C. The camera will automatically fit to the size of the circuit, and we can go ahead and move it around, see exactly what's going on. If I want to zoom in, I can move the camera and zoom into specific gates. Right click to move the camera, and then scroll to zoom in. I can kind of go inside and see what's going on. Obviously, this thing is a big mess because it's so big and the connectivity is messed up, but it just shows the functionality. And then let's say I move the camera away and I can't see anything. Oh no, I lost my circuit. I can just press reset here and you'll get it right back. And then the toggle the orthographic camera mode, we just press toggle here, and then it's just a new way to view everything. And it looks a little more aligned. You can get it from a different spot, but the functionality remains the same. Just reset it if I want to, and then toggle back. And then if I want to make all these Hadamard gates say something else, and I want to pass through a symbol resolver like we mentioned before, I can say hello here, and then add resolvers. And now all of my Hadamard gates say hello to everybody. And then let's say I want to like use the padding factor real quick just for completeness. We'll make our new circuit 5 so that we don't overrun it, and then set padding factor to 2. And now we have a way more spread out circuit, 5 by 5, that we can see, and everything works the exact same. So yeah. So going back to some closing thoughts. Building widgets is easy, but enabling others to do so takes a lot of time. Especially when you're working with developers, you have to make sure that everything is very well defined, everything is well specified, and people know what they're doing, especially because Cirq is an open source code base. And if we expect other people to go ahead and contribute to it, we have to make sure that everything is very well planned out, well thought of, and that people can follow like a good lead in good direction. Choosing the right way to build a feature takes a lot of careful thought. As an intern coming in, I'm susceptible to just wanting to build things very, very quickly. Like I could build a prototype of like the moment filtering thing in like one day, but building it right is like a very key thing, and making sure that, hey, we think about the different alternatives, think about what's actually best for users, think about what's scalable, think about like, I don't know, what's just the easiest or like the most efficient and best way to do this thing. It's something that I definitely learned throughout this internship. And I think that in this feature, there was a lot of thought with Balint. Me and Balint talked a lot about it. So like we made sure that everything was done is very meticulous and done the correct way. And then there's a lot of nuances to the feature that pose some challenges that I wasn't really expecting at the beginning. The bundling for the Typescript environment, I'd say, was the longest. And unfortunately, it took a lot of time. It was not a lot of code. It was a lot of like learning Webpack and understanding like the best way to do it and the most efficient and simplest way to do that. But that was something that I wasn't really expecting at the beginning, but we ended up getting it right. And then like testing frameworks for widgets. So this was probably the first time that I wrote extensive testing. And I think maybe I forgot to mention that. So each visualization and each widget is actually tested with unit tests and end-to-end tests. So we have obviously unit testers that test for like the existence of 3JS meshes, the locations of the meshes, whether or not things are like doing the things that they're supposed to be doing. But then we also have end-to-end tests that will literally take a screenshot of the different visualizations and then compare pixel to pixel if it's a 100% match. And building those tests into the framework and making sure that there's full coverage, making sure that if people modify different things, they know how to go ahead and change the test. That kind of posed a challenge to me that it took a little bit of growing pains getting used to, but I ended up getting, I hope, pretty decent at that at the end. And then circuit serialization was another one where the implementation of it wasn't the most hard, but just wasn't the hardest, but it just thinking about how we were going to go ahead and serialize it and figuring out what we wanted to do was definitely a challenge point. But once we figured out how we wanted to do it, it was very easy. And then finally, before Q&A, I want to give just a special thanks to everyone who helped. First of all, Balint, my host. Balint is a beast. Balint was he pushed me so well and like make sure that I did the best work like for the entire internship. But I also know that he cares a lot, right? And just wants the best for me. And it was the perfect balance between like working as hard as possible and like making sure that I did a good job, which I really appreciated. Will was the same way. Will would leave a ton of comments on my PRs. Like I think the first one was almost like 100. Like the very first video was like 100 comments. But I love doing that. So because like it makes sure that, hey, if you're going to build this feature, if you're going to do things, you have to do it the right way. You have to do it to the standard. But both of them too were amazing hosts. You know they care. You know they really like wanted to do the best and wanted me to do my best. And it wasn't like, oh, I'm just going to nitpick. They really wanted me to do good work. And so I'm very thankful for that. And then like Craig, I went back and forth with Craig a lot about the 3D circuits. It was kind of funny on the PR. He built these like super large circuits and put pictures of them in the thing. And at first I was a little like intimidated seeing this. I was like, okay, I have a lot of work on my hands. But he was really awesome just chatting with him and talking about it and kind of bouncing things off. Ryan, thank you for the reviews and like dealing with and like just I know you have another intern as well and you have a lot on your plate, but thank you for taking time. And then Suresh with design, obviously, and then Kevin with just the requirements and making sure. I think I remember talking to him like earlier in the internship, and then even more recently about getting some different circuit designs to go try stuff around. So big thanks to him. And then obviously the entire Quacks Quantum Open Source Cirq maintainers team. This whole internship, just listening to my RFCs, providing feedback, listening to drawings and presentations. Like this feature is all of our work. And I'm very thankful and very grateful for everybody. So I really appreciate it. And then Q&A time now.
Yeah, so thanks for the presentation. It went really well. So we have one question from the chat. So Victory asks about circuit serialization. So does that mean Cirq.to.json was too hard to use? And what could we do to improve Cirq to JSON to do what we want in order to use it in this case?
Yeah, I think the issue wasn't necessarily that Cirq.json was like too hard to use. It was just that it kind of provided a lot of extra information and it took a lot of extra steps to like build different meshes out of that was really needed. Like, for example, and from what I remember, because it's been a minute since I've like looked at it, but obviously different type of gates have different types, which then we would have had to traverse and build certain like serialized like Python objects or Python things based off of. And going through and traversing that whole thing, it's just sort of like an unnecessary extra step that we could have very easily mitigated by just iterating through each moment of the circuit and building it our own way. And it's basically the fact that one, it's not really like necessary for what we're doing. And two, like if we were to use it, I think we could have made it work, but it would have been an unnecessary step that we could have just avoided altogether by just doing it ourselves. So I hope that answered your question. I'm not super familiar with like the ins and outs of Cirq.to.json because we spent probably like 2 days maybe thinking about it. But yeah, that's kind of the rationale behind it.
Okay. Next question. Daniel raised his hand. Thank you for raising your hand, by the way. Do you want to ask your question?
Yeah. So do you have any documentation for this? If you want this to kind of live on with new developers and perhaps users who aren't looking at this right now, yeah, you'll need a documentation to lead them along.
Yes. So in the readmes of each like package or each folder, directory, I'll call it, it tells you exactly how to go ahead and both run the visualizations and also add new visualizations to the to Cirq. So off the top of my head, if you like in the root Cirq web directory, there's a general like quick start guide, which will show you how to go ahead and create a block sphere and how to like generate an HTML file and how to display it in a Jupyter notebook. If you go into the Cirq_TS directory, there is documentation on how to build a new widget. There's documentation on how to test it, how to use the different check scripts, how to make sure everything is formatted, how to run things in a browser for hot development and hot reloading. Testing, I think I may have already said that, but there's all that is in there. And then on the Python side, there's also documentation both on how to use and how to build visualizations and link them end to end. I think as if this makes it to like the Cirq reference that's public online, I'm pretty sure that we can just pull from those README files and make it publicly available. But there is a good amount of documentation as well. And obviously for the circuits, I'm going to go ahead and probably either today or tomorrow before my internship ends, push a quick PR, adding some documentation for that as well. So yeah.
Thanks.
Any other questions? I saw Orion commented that he's used the readmes. Okay.
How much of a pain was it to add the zoom towards cursor?
News, I didn't add it yet. It's not going to be too hard. Three.js has a custom raycaster thing where you can just kind of get the vector and then like display it from there, like you said on the PR. Just for the scope of this, we have to make sure that we got everything merged in before the end of the week. So all of that extra stuff we omitted. But the good thing about this thing is it's open source, which means that let's say I want to work on it next week, I can work on it next week, and it's yeah.
Yeah. Cool. Congrats.
Thank you.
Yeah, that's a great idea, Victory. I don't think we have a great place to put this on YouTube, but I can ask around and see if there's a good place to put this. Any other questions? And I guess we'll open it up to general questions as well. Either questions about the presentation or questions about Cirq quantum computation, anything from our new folks. Okay. I'm going to stop the recording here.